All right, pretty excited. This is a how-to video on how to divide using polynomial long division. And I know right now you're thinking, yeah, division's great and long division's even better, but even more exciting than polynomial or long division is polynomial long division. And the cool thing is polynomial long division uses the same algorithm as normal division. So in normal division you have a number and this one, and you'd ask yourself, what do I have to multiply this by to get 12? And you'd say 3. And you subtract, and then you follow along this algorithm until you're done. So the same rules apply to polynomial long division. And the one thing that we need to make sure is our numbers are written in descending order of degree. So the numerator's largest degree is 12x squared, so I have to write it first. My next one is positive 19x, negative 21, and we need to divide it by 4x minus 3. So the question becomes, what do I have to multiply 4x by to get 12x squared? That's right, 3x. So 3x times 3x is 12x squared. Great. But I also have to multiply this by this. 3x times negative 3 is negative 9x. And now I will subtract. 12x squared minus 12x squared is 0. 19x minus negative 9x is going to be positive 28x minus 21. And so the question is, what will I have to multiply 4x by to get 28x? And the answer is 7, right? Positive 7. So we're going to do, that's a 2. This is a 7. So 7 times 4x is 28x. 4 times negative 3 is negative 21. I subtract, and I get 0 and 0. So I know that this numerator divided by this denominator will have a solution of 3x plus 7. Now clearly you could have done this same problem by factoring the numerator and then just canceling out the factors. But the problem is sometimes we have a denominator that doesn't go evenly into the numerator. Enter question E. So same idea. We need things in descending order. So y to the third is clearly the largest degree here. But the trick here is we also need to include all of the degrees less than to the third power. So we need to include y to the second. Now, you may say, wait a second, there are no y's to the second here, and you'd be right. But we still need to include it for our division. So how many y's to the seconds do we have in the numerator? Well, we have exactly 0. So I can use this 0y squared as a placeholder. Likewise, using the same logic, I need y to the first as a placeholder, and now I have my 4. And I'm going to divide this huge thing, although it's not really too big, by y minus 1. Alright, so what do I multiply y by to get y to the third? Y squared is right. Y squared times y is y to the third. Y squared times negative 1 is negative 1y squared. And this is why we need our placeholder. Y to the third minus y to the third is 0. 0y squared minus negative 1y squared is positive y squared, because a negative minus a negative is a positive. I'll write the 1, and I'm going to bring this down, plus a 0y. Alright, what do I have to multiply y by to get 1y squared? Well, just y, right? Y times y is y squared. Y times negative 1 is negative 1y. Subtract them. 1y squared minus 1y squared is 0. 0y's minus negative y is going to be positive 1y. Bring the 4 down. Plus 4. What do I need to multiply y by to get y? 1. 1 times y is y. 1 times negative 1 is negative 1. And so I get, when I subtract them, 5. Because 1 minus 1 is 0. 4 minus negative 1 is 5. but I don't have anything else here. Now, unlike in traditional long division, where you just put a decimal and add zeros, we're not going to get anywhere with that. So at this point, our answer is plus 5 over y minus 1, because that is my remainder. And you remember how to write a remainder as a fraction when you do division. So my final answer is this not quite beautiful thing. All right, so what I want you to do right now is I want you to go and open the visual picture of the guided practice. And once you've done that, I would like you to please try it. Once you've tried the problems, see if you got it right by watching the video that says Polynomial Long Division Guided Practice.